S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So in part 1, we did Rolle's theorem statement we understood, then we did the geometrical interpretation of the Rolle's theorem. 2 questions we have already done, but hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Now in this part 2, I'll be taking the questions where the root concept of Rolle's theorem is connected, and let's see. I just take up my first problem, and that is between the question says that show that between any two roots of e to the power x cos x equal to 1, there must exist one root of e to the power x sin x minus 1 equal to 0. This problem is of Rolle's theorem. Why? Because between two roots of this function, there must exist one root of this. And what Rolle's theorem, I just write in short. Suppose you are given a and b values. This interval we take in Rolle's theorem. What we do? fa, fb and function derivable and function continuous we check. After these conditions, obviously this function, if we are applying Rolle's theorem, this function has to satisfy Rolle's theorem conditions. Then after these conditions, we take the derivative of this function, and easily we can link, if we are applying Rolle's theorem, then this function derivative should be this function. That you have to check, then only you can apply Rolle's theorem. Anyhow, we can easily see that derivative of this function is this function. This is first verification. And now I am checking and verifying whether this function should satisfy Rolle's theorem. It should be derivative of this function. Then easily we can say between any two roots of this function, there exists one root of this function, because this says that derivative function will be 100% 0 at some point, and this some point lie between the open interval AB. So this is how we relate and we identify that where to apply the Rolle's theorem. So the solution part, because we are given that e to the power x cos x equal to 1 has two roots. Two roots means let alpha and beta be two roots of e to the power x cos x. Suppose this is my function. This is the function. I have written it in function form. So this is the function. Roots means f alpha. It means you put instead of x you put alpha. This I should not write 0. This is my function. So f alpha is this, f beta is this, and we are given that these are roots. It means this value is 0 and this value is 0. Now, so we have considered the function e to the power x cos x minus 1. Again, I write this function in this form because my function is e to the power x cos x minus 1 equal to 0. What I'll do, I just divide it by, just take it to this side. So it will be cos x minus e to the power minus x. This will be the function, and the thing is, if you are writing it as it is, the derivative will not come in this the same expression. So I am just changing it to, and the reason behind this is that derivative should come to exactly the same expression. So the same function, and don't be like that I have written a different function. only what I have done, I have taken this e to the power x to this side, and if I am taking it to this side, it will become e to the power minus x, and then I have taken it to this side. That's it. Divided by e to the power x and take it to the left. This is the function I am considering, because I have to get the derivative in this form only, and the reason behind this is that only, that we that the same derivative we need to get. So this is the function. Now f alpha value is this, and that is 0, because this is how the function is, e to the power l alpha cos alpha, minus 1 will be 0 and beta will be 0. So one thing is f alpha, f beta is 0. Now it means this implies f alpha is f beta. This is the third point. Now number f, I am checking to check f is first I will check continuity. So f is continuous or not, we are checking it. So my function is cos x minus e to the power minus x. I have written it in a different form. So cos, everybody knows this is continuous, e is continuous, subtraction of two continuous function is continuous. So it means this is continuous. There is no problem in continuity. This is continuous. So now derivable, to check derivability. So to check derivability, what to do? Now again cos x minus e to the power minus x, this is derivable. Cos function is derivable, e exponential function is derivable, subtraction of two functions is derivable. So easily we can say that this function is derivable. So all the three conditions on this function, this is the function I am discussing or I am talking about. Cos x minus e to the power minus x, I took the function. So this is my function cos x minus, we are given that this this particular function, this one has two roots. So two roots I assumed, alpha beta, f alpha 0, f beta 0, then f is continuous, f is derivable. Here all the three conditions are satisfied. Therefore we have to check all the conditions. If any one condition is failing, we cannot apply the Rolle's theorem. All the three conditions of Rolle's theorem are satisfied, and in which interval? In the interval alpha beta, because corner points, the value f alpha f beta was same. It means in this question the alpha beta will be the interval. Therefore there must exist some c such that it will be in the open interval alpha beta, such that the derivative of the function and at c will be 0. My function was cos x minus this, now differentiated. So f dash c 0, this is the function. Instead of x you write c now, because this is f dash c. So the derivative is minus sin c plus e to the power minus c equal to 0. Take this term to right side and then divide. When you will divide it or you will take it to this side, it will become positive, and it minus 1, minus gets cancelled. Finally this is the expression we are getting, and you can compare variable anyhow. This is c variable, and in the question it is e to the power x sin x minus 1. There is never you write fx or fc, it hardly matters, both are the same things. It means what we were supposed to, we have proved that between any two roots of e to the power x cos x equal to 1, there exists one root of this function, and it has been done by the Rolle's theorem. So this is the question and it is proved. Now I am taking another different problem, and that is, so I have written the question already because it's a big question, and the question says that prove that if a0, a1 till up to an are real numbers, all are real numbers, such that they are satisfying some condition, and that a0 by n plus 1, a1 by n plus and so on an equal to 0. It means there is one condition which is given, and that condition is that some real number, some expression is 0. On the basis of this condition, the question is asking that there exists at least one real root between 0 and 1. It means interval is 0 and 1 such that this is 0. Now, how we relate it to Rolle's theorem? We can relate it to Rolle's theorem by the fact that this expression equal to 0, and in Rolle's theorem we get some function derivative equal to 0. It means this is some function derivative equal to 0. This is the indicator or indication that we integrate it, and that function we have to assume. This is derivative of any function, and if we want to know that what exactly that function is, it means we have to integrate this expression, and we have to assume that expression as a function. So let fx equal to the integration of this I am doing, and integration is xn plus 1 upon n plus 1 a1 xn upon n, because we add in the power 1 and then same thing we write in the denominator, and so on an x equal to only the function. So this function I am considering. Now, if this function is derivable, this function is continuous, f0 is f1, we can say we can apply the Rolle's theorem. We will differentiate, and 100% the derivative of this function will be this, and as per the Rolle's theorem this will be equal to 0. So this is how we will be proving or solving this question. Now, f of interval we will consider. Interval will be f is continuous in the interval 0 to 1 because it is polynomial. Since it is polynomial function, every polynomial is continuous. As this is number 1, as every polynomial is different derivable, therefore f is derivable. So two points are already satisfied. Now the last is f0 has to be equal to okay, f is derivable in the open interval 0, 1. What is f0? Because everywhere we have x, so when we will substitute x0, it will be 0. What will be f1? f1 will be a0 upon n plus 1, a1 upon n plus and so on an, and you can see this is the given condition and you can compare it. So this is the given condition exactly, and in the question it is given that this is 0. It means f0 equal to f1 and equal to 0. All the three conditions are satisfied. On the basis of that, we can say that all the three conditions are satisfied, and three conditions of Rolle's theorem are satisfied. Therefore, there must exist a C such belonging to the open interval this such that the derivative of the function at C will be 0, and 101% the derivative will be a0 xn plus 1 a1, because the function is, when you will differentiate, n plus 1 xn, so a0 xn, n plus 1 will get cancelled, then a1 xn minus 1. So it means the first term will be a0 xn, a1 xn minus 1 and so on, an equal to 0. So you can see the root problems we can connect with Rolle's theorem. So this is the end of part 2, and in part 2 we have taken two good problems where we connected the root of a function to root of the other function. It means between any two roots of a function, if there is existing the derivative function root, it means that is Rolle's theorem. That connection I have done. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. If you like the video, please do like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.